Hello everyone. So in this series, we've written SQL to do every type of operation to our data. We've inserted it, selected it, updated, and even deleted it. At this point, you're masters of your tables and all the rows that they contain. In this video, we're going to explore how people write code to interact with their databases when they don't have quite as strong a command of SQL. We'll explore an ORM library called Sequelize, and see how this library allows us to approximate simple queries with a function-like interface. We'll also sneak in a bit more practice with endpoints, review how cookies work on the server, and then see how we can combine our database with cookies with endpoints to create a simple authentication system for our web applications. So with all that said, let us begin. For this app, I've actually coded up the shell for us, the stuff that's the same every time already, created my Express app, attached a router, have it listening on a port, and the router doesn't have any endpoints yet, but it creates itself, it exports itself. What I'm going to do first is I'm going to start introducing Sequelize. So Sequelize is a library that enables us to do a lot of the same things that we do with PG. Because it's a library, I will need to import it, so I can import Sequelize from Sequelize, if I can type the name of it. And this library needs to be instantiated very, very similarly to what we did with PG. I say I want to make a new Sequelize connection. And inside of here, I'm going to put the host of my database. I'm going to put the port number. And for this, I'm going to use all of those same details that I've been using in all of our videos so far. My local database with my user account, and my database name will be database demo. So this is exactly what we've done with PG. The one extra thing we have to do with Sequelize is tell it what kind of database this is, what flavor of SQL we're speaking. And that is because the PG library is specifically for Postgres, but Sequelize actually works with any type of SQL database. So I've now added the dialect, and I'm also going to set logging to false. By default, Sequelize will print out all of the queries it produces. That's great for debugging. Definitely remember that this option exists if you choose to use this. But most of the time, I don't want to flood my terminal with a bunch of extra text. So doing this, I've now established a connection to my database, or at least defined the parameters to do so. In Sequelize, the first thing we do is create models for each of our tables. So the kind of conceit of these ORM libraries is you're taking your tables and flipping them on their head, turning them into object-oriented classes. So if I wanted a app user class in my database, so an app user table, I create an app user class in my JavaScript program. And I say, I've got this thing app user, but I add this extra detail afterward that says app user is a type of Sequelize model. So this base class model is what works the magic to make it so that our class can actually be recognized and attached to its table. And the first thing we do with this is I say app user, I want to initialize you. And we pass init two arguments. The first one is a giant JSON object that represents all of the columns of our table. So if my app user has a name column, I put name as a key in this object. For the value, I'm going to put something that represents the JavaScript type. So for us, that's going to be Sequelize.datatypes.name is going to be a text column. So I'm going to add text. Password, also a text column. So I add text again. Maybe I'm making a social media app, so I decide, oh, I also want each user to know how many posts they've created. And that one's going to be a data types dot integer. So for simple columns, that's all I need to do is say, here's the name of the column, colon, here's the type of the column. If we've got a more complicated column, one that has a constraint or one that is special, like a primary key, I can say ID is the name of this column, but instead of just putting a data type on the right, I can create an object inside the definition of this column and say, oh, well, the type of this thing is Sequelize data types integer. But ID is special. It gets more details, like the fact that it is a primary key, like the fact that maybe it should auto increment. And any extra details that you want to put for your column, you can do so inside of an object here. But this gives us a nice schema of our table all in one place here, where we've described all of the columns that belong to this table with all of its type information. Once I've done that, I have to pass a second object to init, and that is just a reminder to Sequelize what database this table is attached to and what it will actually be called. So I pass it my database connection and my model name, which is just a fancy way of saying what is the actual table called inside of my class. So I'm going to pass in the model name app user, and I'm actually also going to put timestamps false, which is just another one of those extra logging things that I don't really need for my tables. It's worth exploring if you do for yours. But now I've created this definition, and the neat thing about this is app user objects in the rest of our program are going to get each one of these as an attribute on the object. I'll be able to, whenever I grab a user, just do user.name or user.password and get those things. If I also have methods, methods might go in here. So as one example, when dealing with users, passwords tend to be treated with a bit more care. I might realize that I don't want my user's secret password to be stored in plain text in my database. Maybe I've just heard that's something that's not good. Maybe I actually understand that if there was some SQL injection attack, or my database credentials got exposed, or somehow someone got a copy of this table, maybe I don't want to leak everyone's actual password out to the internet. This is a common concern in web development, and the way that we handle this is doing what's called hashing a password. In order to hash a password, you take the plain text that someone gave you, some normal password, and you run it through a really complex mathematical function that spits out an almost incomprehensible string of letters and numbers. So this does two things. First, it takes a long time, which is going to slow someone down if they're trying a bunch of different passwords. And second, it protects that plain text string. One of the nice features of a hash function is you can't easily reverse it. You can't get back the original text that gave you the garbled output. In JavaScript, one of the popular libraries for doing this is called bcrypt. So I'm actually also going to import bcrypt into my database connection code here. And all I need to do in my class is say, oh, well, you know, I need a couple extra utility functions on my app user here. I'm going to say, when you create the user, I'm going to ask you to call generate password hash. And when you give me a plain text password, I'm going to return back from this function some garbled version of that password, and that will be what we actually store in the database. So my hash will be bcrypt.hash, and then I pass in two things, the plain text password, and then the number of rounds of salt that I need to do. Salt is just a way to spice up this hashing function even more so that every user has its own separate version of the algorithm to produce the hash. This is important because it means even if someone gets our whole database, if they want to brute force a password, they have to do it individually for each user because each user's got this different hash. So this is, again, a promise returning function. So I'm going to await this function, get back some hash, and then return that from my generate password hash here. So I've now extended this class definition with a static function so that I can do AppUser.generate password hash and produce one of these things. This means I also need to handle this when I am validating a login. If I'm trying to find a user, I'm again going to need to take whatever this garbled text is, whatever password they've given me, and compare the two. That's still how we validate a login. That means I need to redo that same transformation, and bcrypt can actually help me with this as well. I can add another function to AppUser called validateLogin, where if you give me a plain text password, this time we're on an actual AppUser object already. I'm saying, hey, is this password that I've provided, the same as the password that I've stored in this garbled format? I can do that with bcrypt compare. And what bcrypt compare does is it takes that plain text password and it takes that hashed password, not encrypted, it's hashed, you can't recover it, and it will look at the salt that's attached to this thing and apply the same salt on top of the hashing algorithm we're using and get this plain text password transformed the same way as this line in the database. And this is going to allow us to check, yes, they do match, or no, they do not match. This result will be a Boolean that we have to await because it takes a little bit of time. And then we can return this result, get back, yes, the user should be logged in, or no, they should not be logged in. So you can see that this is one of the nice things about using an ORM like Sequelize, is most of what you do in SQL is just produce these data definitions, schemas that have columns that have types. With an ORM, I can also attach entire methods to each one of these tables and say, oh, well, here's some extra things that I want to do when I'm working with a user in my code. So now we have defined this app user relation. I had said I wanted to make a social media app, so we're real quick going to knock out a post class as well. Say, oh, well, a post is another model. And when I create a post, I have to initialize it with a description, which each one of these columns will again need a data type. So I'll say for a post has some content, the text that you typed when you made the post. It has some date that it was posted, which is going to be a date. And in a post's case, I actually want a foreign key saying who the author was, what the author ID is that is associated with this post. So just like with primary keys, I can actually specify this using a JSON object. First by saying, well, the type of the thing hasn't changed. It's still data types integer, because that's what it is up here. But now I say this column here of post, it references another model app user, the key ID in that model. And putting a references block like this will have Sequelize go out and produce that foreign key constraint in its actual SQL when it writes the table. So now I have created all of that. I will also want an ID on this post, say that this one also needs a primary key. So I'll make an integer primary key that auto increments just the same way that we did with our user. So now we've got two tables here, and this one will also need to be linked to our database connection, just like the last one. I'll make a posts table. So now these two tables that we've created, this is my data model. And if I were doing this as a real app, I might even pull each one of these out into its own separate file, maybe make a function that I can call that produces the class and then fills in the database connection. But now we've got our data model all set up in Sequelize. The last thing I need to do when I am creating this connection is then actually synchronize these definitions to my database. And the neat thing about this is if these tables don't match the tables in your database, like if your database never created either of these things, when I call sync, it will actually go out and create those tables for me right then and there. So this is dangerous. If you are constantly updating your tables, it doesn't handle updates to columns terribly greatly, but it will allow you to skip the whole table writing process. If the tables are already there, it'll just load them in. If they're not there yet, it will go out and create them for you. So now I have created this database connection, and I want to use this in the rest of my app. So I'm actually going to make an export from this file, export each one of my models, app user and post and the database connection in case I need it directly. And then in my endpoints, I can go and import this thing. Before we get there though, I want to write one more script to start showing you how we use this thing. So once we've created all of our model classes, the promise I gave you was that this would simplify writing our queries, that it wasn't just creating the tables, but also inserting data, fetching data. I'm going to experiment with that by creating a DB setup script to demonstrate how this works. So if, let's say, I wanted to set up my database, the very first time that my code runs, I'm deploying it on a new server, so I need to add in a couple users by default. The way that I would do that in the rest of my app is go and import my model classes from my DB connection. Once I've got a hold of one of these model classes, there are functions on it that allow me to find things, find one thing, find all the matches for a thing, or even create a brand new thing. So as an example, if I wanted to create a new user, the way that I would do that is by calling AppUser.create. And in here, I would say, what are the values in each one of my columns? So the name column will be admin. The password column will be not a password directly. I'm actually going to call that generate password hash so that whatever secret password the user types, I'm not storing that directly in the database. And that was asynchronous, so I'm going to await it. And then I'm going to say, oh, well, by default, the number of posts that this user has created starts at 0. I probably should have even made that a default value when you insert a row. But now I've created this, and the return of this will actually be the created user. When I get this user back, this will give me even the attributes I didn't set here, like the ID. I can created user.id console log this guy and say created an admin with ID, this ID right here. And I could run this a couple times. Let's say I wanted 2 or 3 users in here. Copy this. Say, oh, well, I'm also going to create a second user with maybe the password something secure. And then maybe I'll even create a third one just for fun. This third one, third guy, I'll give him the password 123. And this script that I've written here gives me everything I need to do to set up my database. I probably wouldn't run this every time I run the app. So first, I will want to install all these dependencies. We've got a bunch of them. We're using Sequelize and Express and bcrypt we had used. And actually, we still need PG even. PG is not used directly by us, but Sequelize, when we told it this is a Postgres database, it's going to try and use it inside its code, so we still need to get it. Actually, I'm also going to use, in addition to that, Express's body parser, and one more actually that we'll cover in just a minute, Express session, that I'll download right now. So now we've got all of our dependencies, and I should be able to run our db setup script. And when I do that, you can see it told me right now it created the admin user with ID 1, second user with ID 2, third guy with ID 3. If I go in pSQL and I log into my database, if I select star from app users, we actually get this table with these users, admin, second user, third user. Each one of them has a password that is not the password that we typed in our program, but is instead this garbled protected hash of the password that can't be recovered, but that we can do that same change to test. And we have our IDs here. So it looks like our script worked. So now that we've done this, what I want to do next is go into our endpoints and see some of the ways that we could apply this. So in our endpoints here, I want to do that exact same import that I just did back in my setup script. I want to import my model classes, and I'm actually going to grab all of them, both app user and post. And then I'm going to start making endpoints that reference these things so that we can see some of these other functions. As an example, if I wanted to make a login for my application, I can say, well, this login, I don't want to put it right in the query string, so I'm going to make it a post. And then my handler for this request, you give me a request, I give you back a response. And the first thing I'm going to do in here is get the username from the request body, and then get the password from the request body. So I've got a username and password here. And normally at this point, we would write a SQL query, select from the users table where the username, like whatever they typed. But if we're using our ORM, I can instead AppUser.find1. And just like our init, this is going to take a big old object that kind of puts in all of the details of the query. It actually looks very SQL-like still. You can't escape SQL entirely. Here in find1, I'm going to say find1, and then in this where object, I'm going to say, well, the name, and then for the name, the Sequelize op equals colon the username. So that is a big old mouthful of operators, little brackets and curly braces, but it's basically doing the same thing that we would do in a select statement, selecting from the table, but then filtering onto whatever it is that we're interested in. In this case, that the name equals the username that we're looking for. And what this is going to give us back, the reason that this is a gain over just writing the query directly, is I'm going to get back a matching user object. And that matching user object, I've already told Sequelize, hey, there should be one of these or none at all if there isn't a match. I'll get back null. So I can check that real quick. Matching user is null. Then that would mean that in my status, I can say, oh, well, that user wasn't found. You can't log in because that is not a valid username. No user with that login. But if I do have a matching user, that thing is going to have all of the methods that we defined for user on our schema. So in our schema, we had said a app user has this function, validate login, and it knows how to validate the login. In my endpoint here, I can make use of that and say, I want matching user to validate his login and call this as a function right on the result of that query. Pass it the password, and it was an async function, so I need to await again. But if it returns true, then I know the password that I was provided, once it gets hashed and mangled up, was the same as the password in the database. And that means that my response can be a 200. It's good, they logged in. I'll send logged in as some text. Otherwise, if there was a user, but they weren't correctly, if their password was not correctly validated, then I can put in a 401, say username or password incorrect. One tiny little security note right here. If we were doing this in a real production app, probably you would want this and this to look identical. You don't want to leak extra information, like whether a user exists at all, to someone who's not logged in. So this would probably also be a 401 with the same exact error message so that someone can't tell whether or not they've guessed a good username, because then they can start guessing good passwords. But in our code here, we've written our login so that we don't have to write the SQL to go out and fetch a thing. We just call a function that gets us back an object and loads it all in. That's most of what a login endpoint does. But the way a session works on the web involves just a little bit more than that. So typically, to manage a session, we give the user who is successfully logged in one extra little token, something that they can hand back so that they don't have to go through the whole login every single endpoint. This session token is normally passed in a cookie because cookies are really good at this type of back and forth and back and forth. We set it once, we can set the expiration right there, and then the browser will automatically attach it to every single fetch in that same domain. It'll expire when it expires, and it won't accidentally get sent to another website by mistake. So to actually create this cookie in Express, we're going to need one additional library here back in our main where we start up the app. I'm going to import Express Session. Just like how Body Parser gives us some extra features related to parsing out a post body, Express Session is going to give us the ability to write encrypted cookies. And these ones are actually encrypted. They have some secure secret that we provide here in our server. So I'll say my session details, my session creator. I call this library that we imported, and I give it some secret password. If I were doing this on production, I wouldn't write it right here. I'd probably load it from a file or an environment variable. Write a age of this cookie, set some parameters on it, like saying the number of milliseconds this thing is allowed to live is 1,000 milliseconds is 1 second, 60 seconds is 1 minute, 30 minutes is a half hour. I want someone, once they log in, to be logged in for a half hour. If they don't do anything for a half hour, then the cookie expires and they have to log in again. We can also specify whether we want to overwrite the cookie, resave it. whether it is a rolling window, whether doing something refreshes that duration each time, and a couple other parameters like what to do when we unset it, and what to do when we are saving it. But this configuration object here gives us the ability to write cookies that we can be confident on the server actually came from us. So now I have set up this thing, and all I need to do is app use it the same way that we use body parser. Just attach it right into our router or our app before the router. We want to do the router at the end, so that we've already attached all of our middleware, our body parser and our session. But with that extra addition made, back in our endpoint, now we can say, oh, you've been successfully authenticated. Great. That means your request session, your session state lives on the request always, even though we're sending it in the response. I can say your user ID is this matching user, his ID. Whatever that ID is that's stored on this object we fetched from the database, I am sticking that into your session so that I can read this out, know it came from me, and know that I, in the past, gave you this number right here that is your username or your user ID. So how we would use this is if we had another endpoint where we cared about this, if we had another endpoint where you're only allowed to do this thing if you're logged in, like say making a social media post, a post to our post, getting a little bit more restful again with our endpoint name. In this endpoint down here, the very first thing I can do is check whether or not this session exists, whether I've given you one of these tokens in the past. If there is no request session, if you don't have any cookies at all from me, you're not logged in. Or if request session user ID is null, then I don't have which user you are. Your cookie has either expired or it represents someone that I don't know about. So I'm just going to fail out immediately. I'm going to say status 401, you are unauthorized. Maybe send a little message, you must be logged in to make new posts. And that's going to stop someone right there from even running the rest of this endpoint. And then I can do my normal validation. I can say, well, if there's no content to your post, then maybe that's a bad request, a 400. But otherwise, I can go and do the rest of my endpoint, and anything that's inside of this else here, I'm confident that my user is actually logged in and that I know who they are. I know who they are because I can fetch it off of that session, that logged in ID that I stored back in login. I fetch it out right here, and then I can make another database request. That current user, await app user, find one again to go and fetch him exactly the way we did last time, where his matching ID is that Sequelize op EQ, and then in there put the logged in ID that we just fetched out of our session. And this gets me that user who is an object just like last time. I've got all of the information from my table refetched from the database. Another note here, if I were doing this in production, I might create some other middleware to do this, some function I could call that would do this general structure, maybe pass in the body after I authorize so that I don't have to rewrite it each time. Just pass in whatever you want to happen and call it after this, pass the current user back. But in our case, for creating a post here, if someone has provided me this body content and they are a logged in person and I've got all of that built up, all I need to do now is create the post exactly the way we created our users back in the very beginning. I'll say the content of this new post is request body content. The date posted is right now, which in JavaScript, you just make a new date object, and that's right now. And the author ID of this post is that current user, the one who's logged in right now, his ID. And that's one of the great things about having our user object refetching him back, or even just using this logged in ID here, is that I can stick it in as an attribute to this object that I'm passing to create, and it does all of the joining for me. I don't need to make a subquery or anything to build out this new row. So I have this created post that I created. It will actually run when I await this create. And then I had been keeping track of the number of posts on my user. So current user, I want his num posts created to go up by 1. If I am making a change to this object, that still is attached. Sequelize knows what columns are associated with each one of these attributes, but it's not going to automatically update the database. If I've changed one of my ORM database objects, I then have to call a save function on this thing that I've created to say, hey, this current user, I've changed his attributes. Go figure out which ones are different and write an update statement for me. So now we've seen how to create, how to select, and also how to update. And you can delete like this as well. You just call delete. But all of those things that you can do with manual SQL queries, you can also write out here with an ORM by calling functions on our model classes. So if I were to finish out this endpoint, I can say, oh, well, you created a post with the ID created post ID. And now we've written an authenticated endpoint, one that only works when you are logged in. If we were also going to go and build out a client side, then probably we would want to change the layout of our website depending on whether we were logged in or not, whether there is a session cookie that isn't expired. You can check for that right on your client. The document will tell you it's cookies with the browser APIs. But all you would do is have some login button that sends these things, gets back your cookie, and then refreshes you to whatever your login landing page is. So with what we have here, I do still want to test it, show you it working. So I'm going to go ahead and run my application, then pop on over to my rested client. It's been a while since we've seen this. And I'm going to try to make a post against the post endpoint. Localhost 9999/post. This is a post with a valid body. It's got content. It's got some actual post content in here. When I run it, it gives me back this 401 that you must be logged in to make a post. So if I come back over to my login endpoint, in the login endpoint, if I try to log in as third guy, and as third guy, I type in some random password that's incorrect. When I run this, it tells me, sorry, your password's incorrect. You can't log in. But on the other hand, if I do type in his password, which was password 123, when I run this, it tells me, okay, good, you're logged in. And as a consequence of that, in the headers, it sets a cookie for me. And you can see this cookie is very garbled. I can't make sense of it on the client. If I needed something in the client, I would send it back in the body of the request. Instead of just sending logged in, I might send maybe a whole JSON object with all of the details I got from the server about myself so I can like set up the landing page or something. But now that I have this cookie set, if I go back to post and make the exact same request that I did before, when I send it, it tells me, okay, that's good. That's a valid post. I created a post with ID 1. If I add another one, this is a second post by the same person. When I run this, it creates a post with ID 2. If I swap back over to my database and take a peek on database demo, when I select star from posts, it kept track, author ID 3, that third guy that we created, on the date that the post was made. We have all of his content. We've now created an endpoint that responds to what happened in the endpoint before, which is really all that a login is. So in summary for this video, we've looked at this ORM library, Sequelize. It's not the only one out there. There are dozens of these, but they all work something more or less like this, where you create classes and then call functions instead of writing queries. And we've looked at how you can validate password information securely in your database by fetching a matching user and using password hashes with bcrypt. We've used that to create an authenticated endpoint where cookies send a session token back and forth, and we can avoid having to recheck the password every single request by just checking whether someone has a session cookie that we can ensure we created on the server. In our case, because we're using our express session and its secret password. So from here, what we're going to be looking at next is some of the other very modern technologies, things that are still in development or very new on the web. So I look forward to that, and I will catch you all in the next one.